On this channel, we provide useful programming information with practical code examples. This time, we cover Shared Worker in TypeScript. We will explain Shared Worker in TypeScript with practical examples. Enabling subtitles will make the code descriptions easier to understand. Shared Worker is a single worker process shared across multiple tabs, windows, and iframes on the same origin. By using this, you can handle shared state and resources across multiple browser tabs. For example, you can efficiently implement a shared WebSocket connection, cache and queue processing synchronized across tabs, and mutual exclusion. Unlike a dedicated worker, a shared worker receives multiple message ports via the onConnect event and can multiplex communication with multiple clients. In the following cases, using a shared worker is appropriate. When you need shared state or mutual exclusion across tabs. When you want to share a single WebSocket connection or IndexedDB access. When you need to notify all tabs, broadcast. When you want to centralize heavy processing to conserve resources. Conversely, in the following cases, other approaches are more suitable. When you need cache control or offline support, you can use a service worker. For heavy processing that is confined to a single tab, you can use a dedicated worker. Here, we'll implement the following step by step using TypeScript. Type Safe Message Protocol. Promise-Based Request Response (RPC). Broadcast to all tabs. Heartbeat and client cleanup. Create the configuration to compile each source file that uses a shared worker. In tsconfig src.json, enable DOM and web worker type definitions so the code can be compiled safely. The foundation of communication is a typed message contract. Defining this upfront makes subsequent communication safe and easy to extend. Request action is a discriminated union, tagged union, that represents the types of requests sent to the worker and defines operations such as ping, get, and broadcast. Request message defines the structure of request messages sent from the client to the worker. Response message defines the structure of response messages returned from the worker to the client. Broadcast message defines the structure of broadcast messages that the worker sends to other clients. Worker in message is a type that represents all messages the worker receives, such as requests, heartbeats, and disconnect notifications. Worker out message is a type that represents response or broadcast messages the worker sends to the client. Random ID is a function that generates a random alphanumeric string to use for message IDs and the like. In Shared Worker TS, register tabs that connect via the onConnect event and handle messages. This directive instructs TypeScript to load type definitions for web workers. Imports the type definitions used for worker communication. Explicitly declares that self is the global scope of the shared worker. Client is a type that represents each client's identifier, communication port, and last heartbeat timestamp. Manages the list of connected clients, a key value store, lock state, and timeout durations. Send is a utility function that sends a message to the specified port. Respond generates a response message for a request. Broadcast sends a message on a specified channel to all clients. Handle request processes incoming requests by type and returns the results to the client. In this code, depending on the type of request received, it handles sending and receiving messages, retrieving and saving data, and broadcasting. This code implements the process for a client to acquire a lock for the specified key. If the lock is not already held, it is acquired immediately. If the same client requests it again, the request is also treated as successful. If another client already holds the lock, it retries every 25 milliseconds until the lock is released, and if the specified timeout, default 5 seconds, is exceeded, it responds with an error. This code releases the lock held by the client and returns an error response if the client lacks permission or the action is unknown. Handle in message parses messages received from clients and handles requests and heartbeats. Cleanup client removes disconnected clients from the registry and lock state. Uses set interval to periodically check all clients' heartbeats and clean up connections that have timed out. On connect is called when a new tab or page connects to the shared worker, registering the client and starting communication. Across this file, the fundamental mechanisms of a shared worker that enable shared state management and communication across multiple browser tabs are implemented. Next, create a promise-based RPC client. Imports the type definitions and utility functions used for worker communication. Here we define the type of the callback function that runs when a broadcast message is received. Shared worker client is a client class that communicates with a shared worker, sending requests and handling responses. These variables are the worker instance, the communication port with the worker, and a map that tracks requests awaiting responses. These variables hold the client identifier, the timer for sending heartbeats, and the broadcast reception handler. In the constructor, it initializes the connection to the shared worker and sets up message listeners and heartbeat sending. Here it receives messages from the worker and handles responses or broadcasts. Sends heartbeat messages periodically to keep the connection alive. Sends a disconnect notification to the worker before the window closes. The request method sends the specified action to the worker and receives the result as a promise. These are utility methods for basic communication tests and getting the current time. These are methods for storing and retrieving key value pairs. This is a method that sends broadcast messages to other clients via the worker. These are methods that acquire and release locks to achieve mutual exclusion over shared resources. Across this file, a client API is implemented for safe, asynchronous communication from each browser tab to the shared worker. In Demo TS, we use the shared worker client class created earlier and verify its behavior. It sequentially executes a series of functions including communication tests, reading and writing data, broadcasting, and lock handling. This code is a demo that uses a shared worker to share and synchronize data and state across multiple browser tabs. By using message-based communication, you can exchange asynchronous messages safely with loose coupling, making it easier to manage communication between different contexts. In addition, by using RPC, it abstracts communication with the worker in an intuitive, method call-like style, improving maintainability and readability. Let's compile these pieces of code and verify their behavior in HTML. As shown, the processing results and broadcast contents are output to the console. When designing and operating, keeping the following points in mind will help you build a more robust and extensible system. You can adopt a discriminated union, tagged union, that allows branching on kind or type. Use a correlation ID to correctly match requests with responses. Heartbeats and automatic cleanup can prevent abandoned locks. Implement versioning to accommodate future protocol changes flexibly. Defining clear error codes makes UI side handling and debugging easier. A shared worker is a core mechanism for sharing data and state across multiple browser tabs. The structure introduced here provides type-safe RPC communication, liveness monitoring via heartbeats, and a locking mechanism, making it a robust design that can be used as is in production. On top of this mechanism, you can also implement the following applications. Serializing IndexedDB access. Integration and sharing of WebSocket connections. Building a job queue across multiple tabs. Throttling and progress notification delivery. As you can see, leveraging a shared worker makes it possible to share data and processing safely and efficiently across multiple tabs. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. If you'd like to enjoy more content, please subscribe to the channel.